G'day guys. So where we're at the moment is we can place down build orders. So let's build a couple of walls. And what will happen is he'll do one at a time, grab the resources. And each one of those piles only had 5. So he's like grabbing 5, moving it up there, grabbing 5, moving it up there. So it's super duper inefficient. What we want him to be able to do is basically go, all right, so we've got a whole bunch of walls here, actually group those together. So he's going to go, I'm going to get the resource for all of them. He'll find enough wood for all of them, or as much wood as he can find if there's not enough. Go to all, grab all the woods in one, and then walk it all back and go drop, 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 which will make this much more efficient. And watching him do it one at a time just seems, it takes me out of the game. And I think it's going to add a lot. And well, yeah, let's get to it. So the first thing we need to do is, well, let's make something a bit more easy to test. Let's drop more wood down. So that's handled by my terrain. You can see I'm just dropping a bunch of wood here. Let's just drop down a whole crap load. 14, 15, 16, 17, 18, 19, 20, 21, 22. So now we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80 wood sitting on the ground all in a row. Oh, we missed 40. Doesn't matter. All right. So if we drop this now, you can see we've got enough to build all these, but he goes 1, 2, 3, and you can see he's not even finishing one off first. This is a really inefficient way of doing it. If there were packs of 20, he'd pick up the whole 20, but he's only doing one move at a time. So the first thing we need to do, I think, if he's going to know how much wood he's going to pick up, he needs to know how many deliveries he's got to make. So first we've got to group these guys together. So let's work on that first. So we group them together and add up the requirements. So this one needs 20. He needs to go, I need 20, 40, 60, 80 wood, and then go and try and find 80 wood. So I think we should handle that in the task manager. First, we've got the task manager. And this one basically just divvies out tasks. So the tasks are over here. And the way the tasks work is they're actually made from a bunch of smaller tasks. So you've got your task, and it'll be first find the item, walk to the item, pick up the item. So the idea is right now we've actually got a bunch of different tasks, one for each wall. And I think what we want to do is this guy will check. All right, when he gives it out to the pawn AI, and the pawn AI is the one that actually reads the task and goes, all right, I've got to do this one, got to do this one, got to do this one. And it actually basically implements that task. So this one divvies out the tasks. This one is just basically a prototype for the task. It's a blueprint saying do this next, and this one translates that. So I think what we've got to do is we're going to grab this first task, and we'll go, like, if it's a resource delivery task, what we'll do is we'll loop in any other sort of close delivery task, or I might just start with every delivery task to keep it simple, and we'll add that here, sort of link it, and take these off the list as well so they can't be given to someone else. And then when we finish this one, what we'll do is we'll cross this one out and actually just bump this one in its place. And when we finish this one, it'll put this one in its place. And when we finish this one, it'll put this one in its place. And anything that's sort of not finished, if we find, okay, there's not actually enough wood to do these guys, we just chuck them back into there. There's probably a few other ways I could do this. This may not be the best way, but it seems like the way that makes the most sense to me. So let's get to it. So first of all, here is where the pawn requests a task, and we just grab the first task in the queue, erase it from the queue, and then return it. And there's just a little timer we stick on there just in case it gets, yeah, we did that pretty recently. That's just to make sure it doesn't keep, if a task gets returned, it doesn't get given straight back out again. So let's just go right first of all. If this task, task type, this task, task type, requirement delivery. So if it's a requirement delivery task, then let's grab group tasks. And let's just go find resource delivery tasks with same requirements. Not a really creative name, but hopefully descriptive. And based on this task. And let's just make that little function here. And let's make a list. And we'll just go for task in the task queue if the task type equals, basically if it's the same delivery, if it's a resource delivery task. So basically we're going to find every other resource delivery task in the list, but we need to make sure it's the same kind of item. So and task.get target item name equals t.get target item name. Yep. So if it's also a requirement delivery task and it's got the same requirement name, let's go list.append t, and then when we're done, we can return that list. And now we actually need to make sure that this exists in the task of get target item name. And let's just add it here. There. Get target item name. And that's going to return a string. And the way we know the item name, so generally right now the main item, the main task itself doesn't actually know anything. It's just got all these subtasks. And the subtasks are just copies of the upper task, but they're the only ones that actually have task types and target items, because the find item might need something different than the walk to item. So I could just look at the first subtask here and get the item name from that. But maybe, since the main task has this target item and target item type, but the target item is actually the final target where we're going. I tell you what, let's make a little thing here. Get subtask type. It's going to be a task type. And let's say we just go, all right, get subtask, and I just go, give me the find item subtask. I think that's a nicer way to do it. Task item dot target item type, dot name. No, just target item type, because that's already a string. Right, and this guy is just going to go for task in subtasks if task dot task type equals subtask type, return task. If we can't find one, return null. So now we've got an easy way to go, right? Find the find item task. That one knows that. So that seems good enough for me. I think that's nice. All right, so now we can get that target name. And what's your problem here? Makes use of tabs and space. What? All right, so now we should get that group. Let's make sure that's actually working. Let's just go print group tasks and see if we got them. All right. Print assigning task. Print assigning requirement delivery task. Let's just make sure that's actually happening, because I'm not sure why we didn't get the thing appearing in there. Assigning task. Oh, okay. Yeah, this is another problem with the confusing way that I've done it. The actual main high-level task doesn't actually have a task type assigned. The task types are for the subtask. So let's actually go, all right, task type equals task. All right, so now this the high level task is a requirement delivery. So, I mean, that might not be the best that that's doubled here and there, but yeah, the whole purpose of this task is this one. And so this one, a harvest plant, I could make that, task type equals task type dot harvest. That won't affect anything else for this one, but yeah, I think that's the way to do it. Let's base the high level task. Its name is going to be sort of its final destination. All right, that should work now. Now that our high level tasks do actually have a type. Task doesn't have a task item type. It should be target item type. There we go. We can see that's the group tasks. Okay, so what we need to do now is, as we find this group, let's just first make sure there's something in there. So if the length of group tasks is greater than 0, then what we'll do is we'll go task and we'll tell it to group similar requirement deliveries and pass it those group tasks. And we shall also, for T in group tasks, remove them from the queue. And that will prevent them being assigned to some other pawn, which we haven't tested with yet. There's probably a few things that'll break when we add another pawn. I should have been testing with that as we go. Okay, so group similar requirement deliveries. Similar delivery tasks being passed through. And let's just go and add our grouped tasks. And what we'll just do is go, all right, so our total resources needed, let's say it equals 0. And we'll say for task in similar delivery tasks, and we'll go total resources needed plus equals task dot get subtask, and we're going to rely on this one again. And this time, the actual amount we're asking for is going to be here in the pickup subtask. Task type dot pickup dot target item amount. So we've added that to that total resources needed. And then we'll go to the, so that's going to grab the amount needed from all the from all the grouped tasks. And then the actual task we're on now, we're going to go and edit this one, because this is the one it's going to look for finding the items. We're going to actually say, we're going to add this total resource needed to it. So get subtask task type dot pickup target item amount plus equals total resources needed. Okay, so now it's this initial task is now taken on the full load. It knows how many it totally needs. And then we'll just go grouped tasks equals there. So now it's added. All right, so now if everything's working properly, he should just go and grab all the items he needs. Oh no, he won't. He knows how much he needs, but he still only knows how to pick up one at a time. Let's do a quick try. Yeah, so it hasn't actually made a difference yet, except that the tasks for these guys now are sort of stored inside this one and have disappeared into the ether. So now all I have is a bug. Let's keep going. We need to make sure it'll sort of, after it's found the item, walked to and picked it up, if it still needs more, it'll loop back to here and do that again. And that will happen in the pawn AI. So right now, he picks it up and sort of just ends the task. And what we're going to do is in here, we'll add a little thing that if he's picked it up, but there's still more required, he'll loop back. So let's go if in-hand.count is less than the subtask.target item amount. Then we'll go, rather than go back to find item, I think we'll just do the find item here and go straight to walking to it. So the type we want is in-hand.name. We're still searching based on the character position. We're going to grab the closest one. And if the target item is null, sorry, if it's not null, if it's not null, we'll go, let's make a new, because we need to make a little function, tell it to go back to an earlier subtask. So go back to subtask, task.task_type.find item. We'll go back to the find item one. Let's just make this little function first. This is while current subtask is greater than or equal to 0. We want to go past 0. Current subtask minus equals 1. And then if get current subtask.task type equals subtask type, then we'll break. Yeah, so we'll just go back. And while we're here, let's just make a corresponding one. Func skip ahead to subtask type, task type, and this one will go for while not is finished. That's what it was, wasn't it? Yeah, is finished. So it'll keep skipping through and go until we get to the finishing point. And we'll just run on finish subtask. And so I've already got on finish subtask, which just iterates it by 1. And using that instead of just doing this line, it wouldn't make any difference right now, but maybe later I'll do something else in here and this will make sure it skips through properly. And so then basically the same line here. All right, so now we can go back or skip ahead. So we'll go back, but then we're going to go on found item, target item. And what that will do is that will actually sort of skip it ahead to the next one anyway. So we go back to task. Where's on found item? Yeah, it sort of finishes the subtask, but puts the item in there. And since I've got a method here, I'm going to rely on that one rather than doing it sort of manually in the Pawn AI. I don't want to have too much messing around with the actual task internals done here. Mostly I want the Pawn AI just to sort of implement it. So if I can make this guy just send a method to do it for me, that's a way better way to do it. And if we can't find anything, then we'll just go, basically finish the subtask. And let's say, and if we don't have it in our hand, what's going to happen? We'll do that same thing. I think let's do it. Let's give it a try. So he should now, if I do 3, he should grab enough for all 3 first. Oh, yes. Oh, was that not enough for 3? Of course, he's not delivered them all. How much should I put down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 80. So he's going to be carrying 80 wood. That should easily be enough. $80 total. So I don't have to add that up again. So first of all, get rid of that. because we're spamming the text here. Let's just go and print in hand dot count and see how much we're carrying. I really need to make it so I can click on my guy and find out he's carrying, like I did earlier with the trees and the walls. Let's just do 2. It's only carrying 5. Ah, okay. So there's the problem. The problem is that when I'm picking stuff up, it's not adding to it, it's overwriting it. So on pick up item. All right. So let's see. We're duplicating the item. Let's, instead of instantly overwriting that, let's make it temporary number. So there's the temporary one. And if the item isn't too less than, let's make it that temp amount. And in hand dot temp dot count equals amount. All right, so now we're back to the normal thing, and let's go right. If in hand not equals null, so if we're already carrying something, we'll go if the in hand dot name is equal to the in hand temp dot name. So if it is the same thing, then we'll add it. Plus equals the in hand temp dot count. So we'll add to the amount we've got. If they don't match, let's go error. Did you just pick up in hand temp dot name while you were already carrying in hand dot name? There, now we'll be able to see if that happens. Hopefully it won't. All right, and if we don't already have anything in hand, we'll go in hand equals in hand temp and just combine those two together again. I don't need that one anymore. And then, yeah, whatever, remove it from the world. Good. All right, let's see if that fixed that. Good, so he seems to be picking up enough. He's got 55 altogether. All right, so he's holding 50, 55. So he's carrying 55. So I think the pickup part is done. And now what we have to do is make him, after he's done this one, go and actually deliver to the next one, to the next one, to the next one. So how should I do that? So when he delivers it now, we deliver the requirement and then we do the standard on finished subtask stuff. So deliver requirement, let's just check what happens there. Deliver requirement. Okay, so right now, yeah, he'd actually be giving the entire amount to the first one. Let's see if I can see that. So do a whole bunch, and this guy should end up getting like all of it. Yeah, 80. All right. So I just need to fix this. So let's see. The drop amount would be from the current task. And let's make one get delivery amount. I'll have to go and make that in a minute. And if in hand.count is less than the drop amount, and then drop amount will equal the in hand count to make sure I don't give more than what I've got. So now we give it the drop amount and we don't null out what's in hand. We go dot count minus equals drop amount. And then we just go if in hand.count is less than or equal to 0, then we'll delete the empty item in our hand. Oops. All right, so we need to invent this get delivery amount for our task. So func get delivery amount. It's going to return an int, and that will return, let's see, it's going to be really similar to this. Get subtask, find item. No, because that's been updated. So it's got to be from the requirement delivery. Got target item amount. Now that subtask doesn't actually know yet, because the only one that gets the amount, you can see the target item amount only goes into the pickup. So let's just also give it to the requirement delivery subtask, which I think is a fair one to know it. All right, so that should fix the problem with him giving too much. Equals null. Okay, so my problem now is, not problem, what I need to do now is make it so when he finishes the delivery, he skips to the next one. So how shall I do that? Let's go back to my pawn AI. Now when he finishes a subtask, there's an unfinished subtask I think here somewhere. Unfinished subtask, right now he just goes, right, we're finished, we're done. Let's make an exception to that. If the current task dot grouped task is not null, current task equals current task dot next task get next task in group. So go print got next task in group, or else we'll do the normal thing. All right, get next task in group. All right, so let's see. Let's first, next task will just be the lowest one in the array. So grouped, equals grouped tasks number 0. Let's remove at that one, and then return that next task. So let's see, we grab the next task, we remove it from the list, and then we return it. So then the AI will start doing that one. Let me think. Oh, yes. If grouped tasks not equal, if length of group tasks is greater than 0. And what that'll do is it'll prevent the last time this runs from it just going, there's nothing in the list, return well, grab the 0th array from the array that's got nothing in it. All right, so now he's going to start a new task, but he's going to start it from the start. He's going to do the find and everything. So what we need him to do is sort of stop on the, where's the find item? So find item. So he's going to look for, what we need him to do is realize he's already got it in his hand and sort of skip find item, skip walking to it, and then go straight to dropping it off. So let's just make a little function first. Func has item in hand, item name, and this is going to return a bool. All right, so if in hand is not equal null, and if in hand.name equals item name, then we'll return true, he's already holding it. And otherwise, return false. So now, before we look for the item, I can say if has item in hand, has item in hand, subtask.target item type, print, hey, I'm already holding some subtask. Item type. And then we just go current task dot skip ahead to subtask task type dot walk next to. And that should go straight to walking to the final destination. And to make sure we don't do any of this other gear, let's just return and break that. Is that going to do it? Let's give it a go. Let's make 3 to start off with. Nope. Skip, no, I thought I might skip ahead to subtask. Skip ahead to subtask. capital T. Let's give it another go. Geez, if that's all that goes wrong, I'll be really happy here. All right, let's make 3. 1, 2, 3. Did he do it? He did the first 2. He didn't drop the second one. Sorry, he did the first 2. He didn't drop the third one, I should say. And why not? So each one of these guys needs 20. So do 20, 40. How much did he pick up? He picked up, why only 55? All right, let's go and make sure. Where did I write in that 55? All right. So I think we're not actually getting the accurate amount here. Print, picked up, amount, wood, now carrying in hand count wood. And let's do the opposite of that for when we deliver it. Dropped off, drop amount wood, now carrying in hand count wood. All right, so now we should always know how much he's got and how much he's picking up and how much he's putting down. So 3. Oh yeah, of course. Just gotta wrap these in the little string methods, stringify methods. That's the pickup, and same thing for the delivery. All right, let's build 3 walls. All right, so I can see where he's, let's see, picked up 5 wood, not 55. So yeah, he did pick up a maximum of 60. And he did the first one, dropped off 20 wood, he's now carrying 40. Draw 20, now carrying 20. So he's got 20 wood. Why hasn't he done this last one? I wonder if it's to do with it being the third task or if it's the final task is just not being grabbed. Let's give it a go. I think it's more he's not moving to that next grouped task. So what would happen if I made it 4 walls? No, same problem. So he's still carrying 40 and he's just completely skipped the next 2. So what is it about the second one? Why is he not moving to the third one? Oh. Okay, so this one, the first task has the group attached to it. Then he does the second one, but it doesn't have the group attached to it, so it never goes to that second group. I need to pass on the group. So when I get the next task in the group, I need to go next task dot grouped tasks equals grouped tasks. So the task has been removed, the current one, so it's not adding itself to itself. It's taking one off the list and it's adding the list to the next guy, so it's being passed along. So we should be able to build 4 now. Let's give that a go. All right, build 4 walls. 1, 2, 3, 4. Oh, that looked good. Yep, he's got 20 out of 20. Holy crap, it worked. Let's see if it's going to work just generally. So let's build another 4 there. Now there's no items or anything, so let's just tell him to go and harvest a bunch of wood. And so he'll harvest all these. And then the deliver task should be waiting in the queue for when he finishes doing these ones. So let's see if that'll work. And he'll need 2, 4, 6, 8, and he's going to get about, he probably won't get enough from doing these. It depends. We've got 14, 13, 7, probably not enough to do it. So he should, let's see if he can make 3 of them. So we should see him grab a whole bunch of wood and then go. Yep, grab, oh yes. Pop, 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 pop. Yep, so not quite enough to do the last one, but bloody awesome. All right. Oh, I think this last task it might be lost. So that's one thing I haven't checked yet. If this one's not finished at once, will it be lost? I might have to put in a little method to put it back in the queue if he's not finished it. No. Oh, okay. So I'm pretty sure what's happened is my code that he's already got for if he doesn't finish it to give it back, he already does that. That's good. I always had that if he didn't bring it back enough. But what will probably happen if there's 2 in the list that he can't do, it probably will lose the second one of that. So let's see what happens. We do all of those ones. Let's give this one more go. Yeah, and you can see these ones, which were on the end of the queue, and they were never attempted, they actually just got dropped. So I need to make sure when the delivery task gets returned to the queue, it also returns grouped tasks. So it was return unfinished task or something like that. Yes, return task unfinished. So we restart the task. All right. And if task.grouped tasks not equal null for t in task.grouped tasks, we'll just do the same thing. And that should do it. Let's just test that and make sure that works. And so if I just go, well, let's see, we've got enough for 4, 5, 6, 7, 8. So he'll do those ones fine, but he won't be able to do those last couple. Let's go and just harvest a crap ton of wood. And we'll see if he ever, so what I think should happen is this one might have survived, but these ones shouldn't have. So if he does all 4, then we've fixed the problem. All right, looks like he's grabbing enough wood. Let's see if he does all of them. Yeah, he did all. Whew, I think I got it. And just for good measure, let's add a couple of doors. I think the doors should just work. Doors aren't really effectively any different from a wall at the moment. All right. Oh my gosh. I'm pretty happy with the way I did that. I thought it was going to get a bit more convoluted, but I think it seems really, in the end, not as spaghettifying as I thought. And it's still sticking with that general philosophy of this guy hands him out, this guy keeps track of the task and just is basically a list of what to do, and then this guy does all the work. I think I've kept that philosophy going, and I've not made it too sort of spaghetti-y, and I've not made it too complicated arbitrarily, and I think it should still be able to be altered and changed and added to later on. Some sort of things will need to be added. Like right now, my guy can carry an unlimited amount of stuff. And so what you would probably do is make it so, right, if I had like 1,000 wood here, he would go and grab all 1,000 wood if there was enough tasks to warrant it. So what I would be doing later on is at the start, when it's grouping the tasks, group them by, you know, the maximum amount that can be carried. So that way, if you've got sort of 30 walls, one guy will just take his little chunk, and then if there's another guy, he'll take his little chunk. But yeah, this is coming along. All right, thanks for your time, guys. I think that's enough for today. I think I need to do something other than task management after this. I feel like I've been doing task management forever, and I really want to add some other stuff. What should I add? I probably really should try having 2 guys and see how much it breaks when I do that. But yeah, then maybe I can have them build a little house, put back in the stuff where they need food, and maybe actually get a very minimal playable game happening. I've got to think, what do I need to do that? But yeah, I'll think over that over the next week. Thanks for your time, guys. See you later.